And this would be a nice soluble enzyme. It could chew up the biomass as normal, but we choose these polymers with a special property. And that property is if we gently heat them, they will precipitate from solution, and we can recover the enzymes. This usually happens over just a couple degrees of heating. This allows you to recover the enzymes as a solid. You can take on your monomers here and ferment them. And then if you just lower the temperature, the enzymes will redissolve and return into solution. And now, oh boy, sorry, hit the wrong button there. And now you can actually return these to solution, and you can continue the rounds of biomass processing. And so we developed polymers for this purpose. They're well known, the polymer class. These polymers have this property. Here I'm just showing it in a vial where this is in solution at lower temperature. What is related to this is the organization of the water molecules around the side chains of this polymer then cause it to become entropically unfavorable to be dissolved at higher temperatures. So if you just raise this a couple degrees, you can see these cloud out. And again, the idea is that we would take the enzymes with us. And so we were able to do that. We make these polymers that have a variety of these temperatures. This is showing the soluble polymers going to insoluble polymers, and we can, by adjusting the chemistry, make this work at any temperature pretty much that we want. We typically work with this blue one right here, which comes out of solution at about 47 degrees, 47.4 degrees. So if you run your reaction at 44 degrees, it's all in solution, and if you heat it to about 48 degrees, it all precipitates and you recover your protein. So we did this with a cellulase. This is the N-terminus of the cellulase, where we did our chemical modifications using the techniques that I described and a few others, and it works. What we see here is that we can indeed carry this enzyme now through multiple rounds of bioprocessing. We just simply recycle this thermally and get several different uses out of this. Here we did it for 3 different times, and this is basically when we stopped, showing that we could actually get significantly more overall depolymerization using the same enzyme. And the more realistic case, this is pure